Now let's look at numbers of a real example to illustrate different CPU scheduling algorithm. The first one is called first come first serve scheduling, which can be shortened as FCFS. This is the most simplest one and the easy one to implement and manage. And also this scheduling algorithm can provide the best fairness. That is why in real world, so when you go to the shopping mall, by default, the customers will follow this algorithm to check out at the checking out point. However, the downside of this program, of this algorithm, is that the average waiting time is quite long. Then let's look at a real example showing on this slide. So in this example, we have three processes, which are P1, P2, and P3, and their CPU burst time is 24, 3, 3 respectively. So we support the processes arrive in order P1, P2, P3. Then let's see how the FCFS scheduling can schedule these processes. So we will use a particular chart named the Gantt chart to illustrate this FCFS scheduling algorithm. Gantt chart is a bar chart which can illustrate the start and finish time of each process. So in this slide, we use Gantt chart to illustrate this example. The Gantt chart will start at time 0. According to the process arriving order, so P1 will be put onto the CPU first and start from time 0. And also, as we know, P1 will run 24 unit time on the CPU. Therefore, P1 will be finished on time 24. Then P2 will be put onto the CPU next and run 3 units of time. That is why P2 will complete at time 27. So similarly for P3, P3 will be finished at time 30 because P3 will run 3 time unit. Then we have this Gantt chart. And next, let's calculate the waiting time of each process and the average waiting time for these three processes. First, let's see the waiting time. When P1 arrives the system, so P1 has been put onto the CPU immediately without any waiting. Therefore, the waiting time for P1 is 0. For P2, it has to wait P1 to be finished. Then P2 can be put onto the CPU and do the execution. Therefore, P2 has to wait for 24 time unit, which is the CPU burst time of P1. For P3, it has to wait for P2 to be finished. From this Gantt chart, so we can tell the finish time of P2 is 27. So P3 has to wait for 27 time unit. Then let's calculate the average waiting time of all the processes. So we add all the waiting time together, which is 0 plus 27 plus 24 plus 27, which equals to 51, as I have written down on the bottom of this slide. Then divide 51 by 3, since we have 3 processes. So therefore, the average waiting time is 17. Then let's see another example, which is exactly the same as the previous one, except the arriving order. So in the previous example, the arriving order is P1, P2, P3. For this example, the arriving order is P2, P3, P1. Then let's look at the Gantt chart for this example. P2 arrives first and to be executed on the CPU first. So P2 starts from time 0 and terminated on time 3. Then P3 is put onto the CPU and execute for 3 time unit. Therefore, P3 will be finished at time 6. Then put P1 onto the CPU and execute for 24 time unit. So P1 will be terminated at time 30. Then let's calculate the waiting time and the average waiting time. The waiting time for P2 is 0, P3 is 3, P1 is 6. Therefore, the average waiting time is 0 plus 3 plus 6 divided by 3, which is equal to 3, which is much shorter than the previous example with the same setting and different order. So why this phenomenon can happen, which is related to the concept called convoid effect. The definition of this convoid effect is that short process arrives behind long process. The meaning of this convoid effect is when a process with long CPU burst time occupies the CPU first, so all other processes have to wait this long process to be taken off the CPU. From the previous example, you know that long process P1 arrives first and occupies the CPU for 24 time units, which causes that P2 and P3 have to wait for a very long time to be finished, which leading convoy effect and also leading long average waiting time. Another example is that we have one CPU bound process and many I/O bound process. So for the CPU bound process, the main task is computation, which means the CPU bound process will occupy the CPU for a very long time. For other I/O bound processes, the main task is doing the I/O. They only occupy the CPU for a very short time. If the CPU bound process arrives first, so all other I/O bound processes will experience the convoy effect.